Nuclear fusion is the combination of two small nuclei into one large nucleus. It is also one of the best solutions to our energy crisis.
But how do we harness this energy? Nuclear fusion reactors. This is a small-scale version of what a reactor looks like. Already, larger, more powerful versions of this are currently under construction.
ITER, the International Thermonuclear Experimental Reactor, is currently under construction in southern France. In a fusion reaction, temperature and pressure amount to the same thing. Since our fusion reactors can't get to the pressure the sun uses, we have to make our plasmas hotter than the sun. Another challenge associated with fusion reactors is that they leave plasma ions. This depletes the plasma fuel source, making it harder to sustain the reaction.
This is due largely to the inefficiency of the superconducting coils. These coils hold in the plasma ions for the reactions. For these coils to work properly, they must be supercooled. The temperature, -269 degrees Celsius, is very difficult to achieve and utilizes large amounts of resources, thus making them inefficient.
The fusion reactions generate massive amounts of free neutrons. These neutrons are not affected by the superconducting coils, allowing them to collide with the interior of the reactor, making it radioactive.
But is it safe? Well, of course it is. Synthetic nuclear fusion is incredibly difficult to achieve. Since this energy source requires a constant fuel source and is not self-sustaining, it is very easy to control. If we shut off the fuel supply, the reaction immediately will stop.
The interior of the reactor is in the shape of a donut. Surrounding the chamber, or donut, are the superconducting coils. These coils are evenly spaced around the chamber, creating a magnetic field. This magnetic field is responsible for keeping the walls of the chamber and the ions separated. On the flip side, we have inertial confinement. This alternative method bypasses the use of the superconducting coils by bombarding a pellet of fuel with lasers. These lasers cause an implosion, preventing the particles from ever touching the sides.